Yeah, so thank you, Pune Tech community, for giving me this opportunity to share insights of testing from my side with the audience, and I'm thankful, grateful for this opportunity. So, my name is Monica Patil, and today I'm here to talk something about building the test strategy and integrating it into the CI/CD pipeline. So nowadays we all are moving towards the DevOps and CI/CD pipeline. So as being a contributor in testing ecosystem from last 12 years, so I am continuously trying to improve my testing strategy and uh, including my testing strategy, I want to share this new approach with everyone present here. So, yeah, so let's start with the session. And the agenda for today's session, I'll just walk through quickly with the agenda, like what all slides or what all topics we are going to cover with this particular session. And yeah, so we will see what is DevOps, why we need DevOps, what is CI/CD pipeline, and what are the benefits, how it will be helpful for us, and our main part, a new testing strategy, and how we can fit that new testing strategy into the CI/CD pipeline. We will also see the real-time practical scenarios where the poor testing strategy, how it failed, and what were the consequences. We will be going ahead with the core principles of shift left. So as the technology and everything is evolving, so testing is also moving towards the new strategy, which is the shift left. So we will try to learn more about this, and we will build our strategy. So what will be the best approach and what we should do for the improvement. So we will go through the testing strategy, and which is called as testing pyramid. What all test types we should include in CI/CD pipelines, integrating in testing, like whatever testing we are doing, how we can integrate that into this new concept, that is CI/CD pipeline. What is the importance of choosing right tools, and as you know, everything needs to be measured. So how to measure our success, and with that measured success or matrix, how we can improve more, because every time wherever we reach, there is a scope for improvement. um, so we will go on the, like, from the gatekeeper, how we can, a QA can move to the coach. So it's all about the teamwork. It's not the individual responsibility. So we will just go through how we can improve the QA role and what are the takeaway from this. So let's start with the first one. Why DevOps? What is CI/CD and modern demands? So basically, DevOps is a continuous loop wherein planning, coding, building it, testing the build, monitoring what we have tested, operate, and then deploy it to staging or production like environments, and releasing it to production. So it is a mindset, or it is a culture that brings together the development and operations team. So everyone, whoever is involved in a complete software development life cycle, everyone is equally responsible. So that mindset, coming out of the box, coming out of the silos, that this is my set of work, this is your set of work. So this new approach where it is a continuous integration and development. So this particular infinite loop is called as DevOps. If we go with the, like, formal definition, so DevOps means bringing the development and operation teams together to speed up the software deliveries. is DevOps. And what is CI/CD? So CI/CD, as we all know, the full form, continuous development and continuous delivery. So this approach, CI/CD, has various benefits. It delivers the software faster because here we use the automation techniques, like whatever basic things or a definite set of things which we can automate are integrated. So that increases the software delivery, reduces the errors, because automation is always better than the manual efforts. I agree sometimes manual efforts are required, but in new features and new features, new enhancement. But whatever we have BAU, that is more uh, better to use automation. That will reduce the manual efforts and will reduce the errors. So CI/CD pipelines promotes the teamwork. As I said, it is a collaborative process amongst the testers, stakeholders, developers, and everyone whoever is involved in the software development lifecycle. So it improves the collaboration, increases the efficiency. As automation is used, it creates the um, bandwidth for manual testers to focus on other stuff which are important. So this uh, betters the quality of software and improves the efficiency. And as CI/CD itself gives us the name itself says continuous integration, continuous delivery. That means small chunks are every time delivered, and we get a faster feedback from the teams, QA, and everyone, like whatever is failing, are errors, software errors, or performance errors, security scans. So this increases the better feedback, and we get to time to deliver the things. So this is basically a CI/CD. So core problem is that speed without the quality. See, so major problem with CI/CD nowadays is everyone wants to move with the CI/CD, and
Hey, Monica,
yeah,
Maureen, can you please turn into the slide mode? Maybe that will help us to
okay,
read the slides.
okay, better.
Thank. In a slide mode, maybe a slideshow.
Yeah, yeah, I did that. Can you see now?
No, so Monica, you
No,
have
still.
different another, yeah, another screen. But I think it is readable. Neeraj, I don't know whether you are seeing it on mobile.
No, no, not on mobile. Actually, my screen size is too, you can say, big. So that's why.
Ah, okay, okay. You can use
Is
the
it,
zoom
is it
feature.
better now?
Just a minute, Monica, checking.
I increased the size.
That's fine. That's fine. If this is with me, no issue. You can continue. Yeah, no issue.
Right.
Yeah, much
I
better. Thank you.
increased the size and I am in slideshow mode.
Yeah, yeah, sure. You can continue, Monica. No problem.
Yeah. Yeah. So the major problem with continuous integration and continuous delivery is everyone wants faster deliveries. We are moving towards the speed, but with the speed, there is one drawback, like the number of failures or a path to failure is, or the chances to failure are high, because when we focus just on the speed, not on the quality, there are more probabilities to fail. So how to ensure with the speed, how we can go with the best approach or the best strategy which will lead us to the minimum errors. So this is our, basically this should be our target. So for this we have like major like difference between the traditional testing and how DevOps is better. So in traditional testing, what used to happen, the QAs were kind of gatekeepers. They used to get the code, they used to get a new set of features at the end when a code is developed, that is deployed, and it is gone through the hands of developers. And in DevOps, here we are involved in every step. Like whenever a new feature is developed in the building code is merged to a parent repository, then the build is created. So in each phase, the testing or the testers are involved. So this approach has really made a significant changes. Second is manual test suite, making the process slow and inefficient. So here in waterfall or in a traditional way, releases were of big size. We used to get like huge feature, stories were really big. So this was creating a problem. So here in DevOps, what we did is like whatever the task which is repetitive, which is BAU, and which is really important and required, we are focusing to automate that part. So our major focus is to automate the BAU stuff, reduce the efforts, increase the quality, and to integrate this automation into a pipeline. So now how that we will later on learn in this session. And operating separately from developers. So QAs and developers used to work separately. They were not working as a team. Like QAs and developers were used to be rivals of each other, like creating a bug, then there was a long process, like how the bug is created, then developer will come back to a tester stating this is not a bug. So this whole was a big process, and both the teams were not working togetherly hand in hand like we are a one team. They used to be a separate team sitting at the different locations. But in DevOps, we started sharing the responsibilities, and even QAs are given access to the code. They can even debug the code, they can view the code, see the code. Every time they have good collaboration, they work hand in hand, share the responsibilities, and it became a process, it became a whole team. Like developers, QAs are no more a separate team, they are a part of one whole process who delivers the or a application. So these are the major changes. Bugs used to get encountered very late in the process, where a developer developed a feature, he delivered it to some QA team, and then he started with his next task. And in that late phase, when a code is delivered to a staging or a particular test environment, then again going back, creating a next field. So this was expensive and time consuming, because again developer need to debug the code, he need to put his current task on aside. So this was expensive and time consuming. So here in DevOps, we find the codes very quickly in our initial stages, and it has reduced the cost because we find the bugs in early stage and we have the resolution early. Less number of rebuilds are required, less process is required. So this created really a faster resolutions. So these are the major differences between the traditional testing and the DevOps. So DevOps has proven, or DevOps is really a game changer, which everyone should try to implement up to the certain extent. Immediately changing a process is again very difficult, but yes, we should adapt small steps which will lead us to the towards the success. Okay, so Yeah, so we have a real life example where it shows that how it is a traditional testing way is expensive, and how it cost to the company or to the organization. So I'll just go through the scenario. Imagine an e-commerce site 2 days away from the Black Friday code freeze. A dedicated QA team begins the final testing phase on a new feature. A critical bug discovered in the checkout process, caused by a change made weeks ago, that broke the payment module dependency. So here, uh, the team get scrambled. They are into a panic mode to identify the commit, pooling developers. As I said, the developer has delivered a particular new feature to a team and they have moved to the next task. Now you need to pull them again to the current task for fixing this bug, as it is on priority because we are just 2 weeks, 2 days away from the code freeze. The fix is complex and risky, leading to a dilemma. Deploy, like to deploy it with the risky fix or pull the entire feature set. So if we do both, it's like in either case, there is an issue. Pulling the entire development team and um, is firstly a loss, like we are using their bandwidth here. It is a risky fix. We are not sure if pulling back the feature or pulling back the certain code will fix this particular thing or not. So as a result, failure of release, delayed of weeks, whatever task, whatever time our developers has invested on this new feature is completely wasted. Wasted in the sense that there is a delay. Now, even if uh, it is a week delay, that is really a cost. Like, for example, if I go in simple terms, two developers, 1 week, that is 40 into 40, 80 hours, 80 hours of wastage, that much of their salary, money is wastage, plus the confidence of team, confidence in front of stakeholder, uh, delayed in the commitment. We already committed to business that we are going to deliver a certain set of things. So that is again on the complete reputation of the team or the organization in front of business, that we are not able to deliver what we committed on this particular day. So considering this sort of real-time scenarios, DevOps is a better way or a better path to follow. And this sort of scenarios are actually happened in my team also. I'm currently working in HSBC as a QA lead, and we have faced this sort of situations where it really becomes a panic situations, and it is a monetary loss plus the reputation, because there are so many um, lead generation campaigns and other third party involves which are ready with their set of applications or their set of codes to run when the system go live. So everything gets scattered and there are big escalations. So this sort of situation should not happen. In for that we should be prepared from starting. Yeah. So let's move to the betterment, what we can do, the core principles of shift left mentality. So to overcome this sort of situations, we are coming up, or we are trying to move towards the shift left mentality. So what is shift left? So here it is early defect detection, finding the bugs, fixing bugs when they are cheapest and easiest to resolve, minimizing the impact and cost. So here we are trying to do more of the testing in the initial phase when we have just developed the new feature. So here the rework or the process involved is less, and it leads to cheap bug fixing, and it is effective. Faster feedback loop. Developer receive immediate feedback on their changes, allowing for quick correction and preventing issues from escalations. So as soon as developer is done with the feature development, unit test also involves the QAs, wherein they can easily and quickly get the feedback, which allows developers to fix the issues as soon as possible, and the loop or the rework becomes faster. Like fixing, immediately fixed, he will immediately give his code to the tester. So this immediate feedback really matters. Reduce risk. By integrating testing early, confidence in each release builds. So day by day, every release, developers, QAs, management, everyone builds the trust, and releases becomes the confident. Significantly reducing the overall risk of development failures. Improved collaboration. So here the team is really important, and every member of team works as a, a, a complete whole. Like they work in the process, they work from start to end, and the collaboration increases. Team are connected, collaborated, and it helps in more efficient and more quick responses. Shifting left means moving testing activity earlier in the development cycle. Testing becomes an integral part of building process, not an afterthought. So here, from stage one, we are including the QS. So this concept has really improved, and shift left is really a game changer strategy, which I have practically include in my team, and it is helping. So building the strategy, testing pyramid. So how this strategy looks like. So testing pyramid is a model for building the healthy, fast, and reliable test suite, helping to avoid ice cream cone anti-pattern, reverse of this particular diagram, where too many slow UI tests dominate. So this pyramid works from bottom to up. So unit test is the first stage where testing happens. So whenever new module or a new feature is developed, this
Monica,
phase.
sorry to disturb, but we are still seeing your the bottleneck screen. No pyramid.
Seriously,
Yeah. So if you
I'll
guess,
stop
if you want
sharing
to,
and
yeah, sure,
will
sure. Yeah,
try to.
because we still see slide 4 of 13.
Okay, wait. I will try to change. Can you see now?
Yeah, now we can see the pyramid. Yeah.
Okay. I'm so sorry. Actually, I was
Or
moving.
maybe can you go into reading view, the one which is next to the presenter view? Onto the left of that we have a reading view. Maybe you can just click that. At the bottom there is a reading view.
Okay, once again.
So maybe that might work. Because if you are on a split screen, probably we are seeing the presenter, not the presenting.
Uh,
At the very bottom, there is a reading view. At the very bottom of the screen, from where we start to present, onto the left of that, there is an icon for reading view. Yeah, beside that, onto the left. Yeah, onto the
oh,
left of that. Yeah,
now
yeah,
okay.
sure. That's better.
Mm,
Thank you.
okay. Are slides changing now?
Yeah, they are.
Okay. Perfect. Okay. Yeah, so pyramid, we were on this testing strategy. So basically, this is our new testing strategy, which we are going to use going forward, which will help us to improve. So unit test, uh, test individual functions or components in isolation to verify the building blocks of your application. Extremely fast and cheap. This should form the vast majority of your test. So unit test in traditional way, only developers used to be involved in this stage. But here, what we are trying to do is, as soon as the component feature is developed, QS will also get involved and will try to perform the testing so that before creating a build, they will get a quick feedback like what is getting break, what needs to be changed, what are the bugs. So it will cost us less and it will be a faster as the developer will immediately get the feedback and he can easily at this stage can fix the bugs, which will increase the speed, low cost, and better efficiency. Next comes service API integration testing. Test communication point between the service without the UI to verify the component conflicts. Faster and more stable than UI test. A healthy amount of ideal. So here in while creating the build in CI/CD pipeline, we will automate the certain things, not the UI part, but the performance test. For example, the security scans, which we usually perform. Uh, so security scans, performance, and the build check, that is a smoke. So when we integrate all these tests in the build stage, that will give us the more confidence and the better build quality. So we can then integrate this build or deploy this build into the staging or the testing environments. And after this, a particular certain amount of what we call it, the confidence we have built with the unit test, rigorous unit test, and the integration, uh, then the lesser amount of attention, not the attention, lesser amount of time should be invested on UI and end-to-end test. Test full application flow, that is end-to-end, from the user's perspective to verify critical user journeys. So here, our focus will be to verify the complete journey, not the individual module. Because individual module, we have already tested, we have a confidence, we have gone through the security checks, vulnerability checks, performance tests, and now at this stage, we have a certain amount of confidence that we can invest less time, but a very important full end-to-end journeys. These are slow, expensive, because as all the third parties, all the integrations, all the complete flow cycle is verified. So it takes the time, it takes the involvement of certain third parties or a certain application teams. So this, so keep them to a minimum. So this will be our strategy. Building a strategy, types of automated test in the pipeline. So what are the um, tests we should automate in the pipeline? So there are certain test which we have listed down, which we should implement in a pipeline. So first one is unit test. Run on every code commit to ensure individual function and components work as expected. So whatever small user story or a small feature, a divided feature, which particular short code or a short loop which developer has generated, while committing it to the main mandatory repository, we should involve a unit test, and it should be a automated build test run to every code commit. So while committing, this should be triggered. Second, we can include is integration and API test executed during a CI build stage to verify interaction between different parts of system. End-to-end test run after deployment to a staging environment, simulating user interaction across the entire application. So whatever third parties are involved, so that connections can be tested here. Security and compliance scans. So nowadays in every organization, mostly into banking domains or a telecom domain, I've heard that they have this particular scans for security and compliance to verify that there are no vulnerabilities into the code. Sometimes if there are cases where we encounter vulnerabilities and they are really a critical vulnerabilities, so we have planned, as per my like experience, we have planned only vulnerability releases because they were really important and we cannot move ahead with the code deployment without fixing these vulnerabilities. So static and dynamic analysis are important. So these are static application security testing and dynamic application security testing. These are two different approaches to identify vulnerabilities in the software, and these are like mandatory checklist or checkpoints for code to go ahead. Performance test. After every deployment or every code commit, we should verify that by merging this new thing or new code, the existing performance of the application is not impacted. So conducted against a dedicated production like environment to assess system responsiveness and stability under the load. A smoke test, a small subset of critical end-to-end tests run immediately after any deployment to quickly verify the core functionality. So maximum organizations are moving towards the automation of smoke test because CI/CD is giving us an opportunity for an very small and more number of releases. So every week, every 2 weeks, we are having releases. So after every release or every deployment, it is not suitable or not feasible to invest a certain amount of time in verifying the base or BAU functionality or a build. So this is automated. So these are the particular testing types which we should implement in CI/CD pipelines. Okay. So now next question is, yeah, we have to implement this, but how? Integrating testing into CI/CD pipeline. Developer commits the code. Uh, so developer push their code changes to a central repository, triggers the pre-commit hooks, running the fast unit test and immediate feedback in seconds. Continuous integration server. So pipeline automatically builds the code, packaging into the deployable artifacts. And for this, people are using certain tools. Build the stage, compiles code and run all the unit stage test. The test stage creates an artifacts. Artifacts is nothing but the documentation. Uh, Run integration, API test, and perform a SAT scan. If any test fails, the build breaks, stops, and the team is notified immediately. So here, the best part of automation is that it is a quicker and it will immediately give us the feedback, like where it is failing and with the correct error mentioned. Automated tests are run to verify the code functionality, uh, performance, and the security scans. Continuous delivery and deployment. The application is automatically deployed to staging. So this is like pre-defined in our pipeline. So whenever application is automatically, it automatically gets to the staging environment. Staging is like a production like environment. Post deployment smoke test, UI uh, acceptance test, dynamic application security scans, and optionally performance test can be triggered. So when we deploy this particular set of different types or different set of tests are automatically triggered, and we get a feedback like what all is failing and what is the result. So this is how we these are the steps, or this is how we integrate the testing or different sort of testing, different types of testings into CI/CD pipelines. Now it comes with the selection of tools. So tool selection is really important because on this particular stage only the developers and QS work depends, because if our tool is not enough capable, or if it is giving us the results quickly, but the report which is generated by automation is very huge, uh, developer needs at least hour or 2 hours to verify the error log, then it becomes an issue because it consumes the time. So the tool which we are selecting should be easy to understand, easy to work with, and the reports or the output generated by tool should have like easy reading formats, like easy visible errors, easy to find errors, and some systematic formatting. Less critical than strategy. Good tools add to efficiency. So key tools categories. So here are some tools which I found are good for a testing approach. So for CI/CD, Jenkins and Git library CI. For unit testing, JUnit, um, and other tools are there. API testing, Postman. I have also worked with Postman, so it is quite friendly tool and works very well. Rest assured, UI testing. So Selenium is everywhere. It is proven, or everyone mostly is relying on Selenium because it is user friendly. We don't need to write a long codes. All the libraries are already written. So again, it is an recommended tool. For security scans, See, in most of the organizations, there are a particular set of team which is dedicated for security and compliance. So I just know the names for security scanning tools, which I discussed with a certain experts for security testing, and they suggested Sonar Cube and OWASP SAP. ZAP tools are really good for security scans, and there are certain considerations like minimum debugging time should be there. Like as I said, the report generated by the tool should be very clear and acceptable, uh, clear, actionable reports. Yeah, so these are certain recommendation which I searched. Few I got recommendations from the experts. So these are the tools which you may consider in your future endeavors. Yes. Yeah. What's down? Okay. Yeah. So the next point comes with um, like measuring the success. Even if we do anything, everything, there is a scope for improvement. And for improvement, we always need a measure, right? Or a comparison with where we were and now with the current scenario, where are we and what are the gaps, what we can do better. So deployment frequency, more frequent releases, uh, this is a good part. Lead time for changes, that is a faster code to production. Uh, change fail percentage, fewer releases failure, mean time to recovery. So here we get more time for recoveries, which is a good part. Measuring key performance indicators like DORA, a matrix, help us track our improvements. Additionally, monitoring defect escape rate directly assess test efficiency. Like after the production deployment, whatever the percentage of bugs which are leaked can easily be a good measure to identify um, the effectiveness, indicating bug found in the production versus pre-production, like how much percentage of leakage we are having and how we can improve it. So in the traditional testing, the QA team was a gatekeeper which used to come in the end. And with the current strategy and approach, we are trying to be coach, cultivating the culture of quality. So our major focus with the speed, with the time, with the fast releases deployment is the quality. Whole team is responsible. So here with this approach, the complete team, everyone in the team is equally responsible for and equally will take the ownership. Evolving QA roles. So here QA are not just a, a, a one set of people who will be responsible for only one type of thing, but now QA role is becoming the as that. Like they are involved in development, they are getting more familiar with the code, with the pipeline, with the automation. Less manual testing, more test framework building, and more into test strategy. Quality coach, enabling team to build quality in from the start. So each phase QS will be considered, involved, and which will improve the quality. So here blameless. So here process, focus on the process improvement, not fault finding. So who is responsible for this production issue? Who is responsible for the leakage? So instead of finding who is the fault maker, here as a team, we will be equally responsible, and it will not be the failure for a certain person, it will be the failure of process. So here we are focusing on implementing or improvising our process and not the blame game. So concluding our session, here are few takeaways or the key points which we need to remember. First one is shift left, test early, test often, integrate testing into deployment. Second major point is automate smart, prioritize fast unit test. And here we can use our new strategy, that is a testing pyramid, integrate into CI/CD. So automate testing, automation we used to do from beginning, but automating our testing into pipelines, faster fixes and faster failures. It's a culture, sharing ownership of quality, QA as coach and enabler. So basically all this is not just a process, it is a complete process, or it is a complete culture which we need to adapt, which we need to which will help us with the sharing responsibility, collectiveness and collaboration. So it is a combined effort of a team which will lead us to a success. Yeah, and with this note, this particular session comes to the end. And if you have any questions, then you're welcome. If I have a like solid answer, then I'll try to give the solution.